Hello, this is Matthew, and welcome to what I hope will be a quick video today showing a new offering available in the IBM Cloud for anyone to run their own mainframe running ZOS. So this is called IBM Wazi as a service. I don't know what that's supposed to mean, but Wazi is part of their developer ZOS development offering, kind of related to virtual machines, virtual systems, and basically making development images available to your developers directly. So up in the IBM Cloud, I don't remember when this started, but there's been an option for approved IBM customers, so a small set of people, to try this service out in IBM Cloud. But a few days ago, it looks like it opened up for the world. So anyone with an IBM Cloud account, which anyone can essentially sign up for an IBM Cloud account, can now just go in and, without getting added to any special IBM access lists, create a System Z virtual machine. And one of the operating system images available for those virtual machines is a ZOS 2.4 development image. So thought we'd just go through this, take a look what it's all about, see what it looks like to create our own ZOS mainframe. Of course, this is not free. The kind of smallest machine that appears to reasonably run the ZOS image will cost a little over $5 US per hour whenever you have it running. And of course, as soon as you stop it and delete it, you stop paying for it. So if you just want to play with it for a couple of hours, figure it'll cost you about $10. If you have a new IBM Cloud account, it looks like you get $200 in promotional credit to use in the first 30 or 35 days. So if you just wanted to check out, ZOS for several hours, maybe a couple hours, a few days at a time over the first 30, 35 days, you may be able to get away with it without it actually costing you anything. But of course, as soon as you burn through those $200 in free credits, IBM will start charging your credit card for every little resource you use in the cloud. So as with any cloud service, they get your credit card number up front, and you need to be careful not to accidentally spend money or spend too much money. As much as I don't like Oracle, I will give Oracle credit in their cloud. If you sign up for Oracle Cloud and you put it in the mode of I only want to use free services, unlike Google and Amazon and Azure and the IBM Cloud, it won't let you create services that are going to cost you money in the Oracle Cloud until you actually say, I agree, you can bill me. So the free tier on the Oracle Cloud is actually very generous and also very safe, in that it blocks you from spending money without realizing you're spending money. No such protections in the IBM Cloud or the other non-Oracle Cloud providers. They'll just start charging you thousands of dollars if you leave a service running that costs thousands of dollars a month. So be careful, be aware, as always. In any case, I signed up for an IBM Cloud account. I was able to just use my existing IBM ID, and then I had to give it, of course, my credit card number and some other details, but it'll let anyone sign up. I'm not sure what, if any, country or region restrictions are there, but it was certainly no problem at all for me to just sign up as an individual. And we're brought into the dashboard. So let's just dive in and create our mainframe. If you have just signed up for IBM Cloud, you won't have anything in it. You'll just have a new empty cloud console here. Everything we need to do is under VPC infrastructure. This is virtual private cloud. So we'll create our own little enclave up in IBM's cloud with our own private network. And then we will have our servers inside of those networks. This is where our subnets are. This is where our access control lists and security groups, so like our firewall rules, basically live. And so you can ignore everything else in the menu. You just want to go to VPC infrastructure. Now it's telling you up here, get started on VPC with $1,000 in cloud credits. Use code VPC1000 to get started now. Unfortunately, this $1,000 in credit is not eligible to be used to cover the System Z hardware instances. So we don't get $1,000 worth of free time on System Z, but the $200 you get for signing up for a new account does appear to work for any resource. This VPC 1000 promo code is just for a very limited set of resources. So what do we do first? So just so you know, there is documentation for all of this. You just go to the IBM Documentation Center and look for the product IBM Wazi as a service. And they do have some information here on, there's this whole Wazi image builder thing. This is really tailored and oriented toward, this whole service, of course, is oriented toward companies who have mainframes, and they just want their developers to be able to work more productively by having these little private mainframes they can do development on before stuff then gets moved back to the company's real mainframe, built and deployed to production. So a lot of this documentation won't apply to what we're able to do just as hobbyists, but we are able to use a pre-made ZOS image that IBM maintains, and they'll put that on our virtual mainframe for us. And so you'll see one of these options is applicable. I don't know if it's configuring access to the service. Now this is for getting, let's see, creating virtual server instances. Yeah, how to connect to it. So you can look at the IBM Wazi as a service documentation and then expand the table of contents to creating ZOS VSIs in IBM Cloud VPC. And that gives you a little bit more information about this instance that, that you're creating. But let's just click around and figure it out as we go along, right? So the first thing we need to do is to create our VPC, our virtual private cloud. So you go to VPCs, and you can see there aren't any when you sign up for a new account. So I'll just click Create. And I'm going to create mine in North America, Washington, D.C. I'm not sure if all of the geographies and regions have the System Z offerings yet, but North America, Washington, D.C. does. So I'll give that a try. We'll call this my VPC because I'm very creative. Defaults generally are okay. It will create our default firewall rules, allowing traffic into the networks it creates in this VPC. So it will allow SSH traffic and pings by default. That's fine. We will also need to allow the 3270 port. So we'll have to go in and do that later if we want to connect remotely with 3270. And it'll create these subnets by default, one in each availability zone in the region you chose. And you can see here, we'll just have our private address spaces. So again, defaults here are all fine. And VPCs themselves don't cost anything. So you can do this initial setup. And then as you create and delete your virtual Z instance, you can leave this preliminary setup stuff alone, and it won't cost you money to keep around. Okay, so we'll create our virtual private cloud. Perfect, that created it. It makes funny animal names for the access control lists and the default security group. These are the firewall rules. But that's all we need to worry about for now. The next thing we need to do is store our SSH public key in here. Here we are, SSH keys. So the way that we'll initially connect to the mainframe is over SSH. And also if you were to create a Linux instance, whether x86 or Linux on Z, which is another available offering up here, it's the same way. You connect over SSH. So I'm just going to create a new SSH key. Let's say, let me go back to my terminal window here. And we can use SSH as SSH keygen. Yep. Now, unfortunately, as far as I can tell, the IBM Cloud does not understand ED25519 keys. So we have to use RSA keys, which are sort of stuck in the past, but that's what you got to do. So I'm just going to make a 4096-bit RSA key. I'm going to store this in Let's call it SSH/ID IBM Cloud. And I'll give it a passphrase. Okay, so we have our private key in ID_IBM Cloud, and then it created the corresponding public key in IBM Cloud.pub. So let's look at that public key in the .pub. And this is the public key that we need to paste up into the cloud configuration. So I've copied that to my clipboard, and we will just create an SSH key. I will call it my IBM key, and you just paste that right into the box where it says public key. So if I create that, now whenever I make a new virtual server, this key will be in my list of options of which key I want to allow logins to that virtual server with. Okay, so that's it. We create our VPC and we created our SSH keys. Now we're ready to create our virtual server instance. So I'll hit create here. You're lured in with the nice low $71 a month price for a little Intel box running CentOS. But of course, we need IBM Z with the S390X architecture. So we'll flip over to IBM Z. It'll think about that for a while. And for some reason, it doesn't do the math right when you first switch to it. If you were to multiply out this $2.45 an hour plus 12 cents an hour plus 2 cents an hour for a month, we're already in well over $1,000 a month. So this number will update, but don't get fooled by the $100 a month mainframe. It's in the public multi-tenant cloud. That's fine. Again, I'm picking my region where I created my VPC. I'm going to call this my own Z. And here we can see operating system. You are able to run Linux on Z. You have SUSE, which I think has a little cost associated with it. Yeah, 7 cents an hour for the SUSE license, or Ubuntu is no cost. Yeah, so Ubuntu is free. You just have to pay for the hardware and the disk. But we, of course, want to run IBM ZOS. As you can see, ZOS is very expensive. So it's $2.45 per hour per CPU. So this is an important point. It's not going to run on this one CPU 4 gig box. And in fact, from what I can tell, you really need a minimum of 16 gigs of RAM. And so if I choose this 4 CPU, 16 gig of RAM server, of course, not only does the machine become a little more expensive, 45 cents an hour, but you can see that IBM Wazi as a service ZOS image got multiplied by 4 because I'm now paying for essentially a 4 CPU license of ZOS, I guess. But we probably don't need 4 CPUs. We just want that 16 gigs of RAM. So they have memory optimized instances where you have more RAM per CPU than the balanced instances. So I think the smallest machine that can reasonably run that ZOS image is this MZ2 2x16 image where you get two vCPUs and 16 gigs of RAM. And you'll see that cuts the IBM Wazi as a service cost down by about a half, because now we're only paying for 2 CPUs for that ZOS license, not 4 CPUs. But we still get our 16 gigs of RAM. The machine itself only costs a little under 30 cents an hour. But yeah, nearly $5 an hour just for the IBM ZOS license to run on that relatively inexpensive hardware, given that you're buying 2 vCPUs and 16 gigs of RAM worth of IBM System Z server here. Anyway, this isn't priced such that hobbyists can just run these machines 24/7, right? This is going to be a $3,400 per month machine. And that's assuming I leave it running all month. So you get that $372 discount for, I think you basically, if you run it for 30 days out of the month, you get that discount. So this is much more, at least from my perspective as a hobbyist, like, okay, I want to play around with ZOS for some reason for a couple of hours. I'm willing to pay $10 to have that fun for a couple of hours. So that's the machine, the MZ2 2x16. And here's where you tell it, I want to be able to connect to this machine using that SSH key. So that's the SSH key I created earlier. The rest of the options you can just leave default. You're going to get about 185 gigs of disk for the operating system image, and there'll be a little bit of room in there for your own data sets. You can add additional data volumes. You'll want to check the documentation to see how that works. And the networking, we're going to drop this in my VPC. That's the virtual private cloud I created, and we'll get a default Ethernet adapter. That's fine. So that's it. Click Create Virtual Server, and you will create your $3,500 a month virtual server. The good news is you're charged in, I don't know if it's 1 second increments or 30-second increments, but of course, you're not going to be charged the $3,500 just for clicking create there. As long as you remember to delete it when you're done, you will only be charged for the hours that you actually ran this thing. So this says running, the machine's been provisioned. Now it's IPLing, and it does take a while to IPL. So we will check occasionally and see if we can hit it with SSH yet. But it is going to take a good, I think, 5 to 10 minutes to actually IPL to the point that we are able to connect with SSH. So if you just look at the row here, you can see that it has an IP address, 10.241.64.4. That is, of course, not an IP address I'll be able to hit from my Linux system here at home. That's that's in private IP space that only exists inside of the subnet inside of this virtual private cloud network. So there's a few ways that you can connect to this. Again, if you were doing this for real as a business running these virtual Z instances, you would probably create site-to-site VPN connections between your office network and your VPC here up in the cloud. And then from your machines inside of your office network through your office router, you'd be able to connect to this IP space over that VPN. We're not going to do that. The other option is to create just a small Linux virtual server instance here, and then either give that machine an IP address on the public internet and SSH into that guy, and then from there, you'd have full access to everything running inside of your private network. We're not going to do that either. We're just going to give this Z system an IP address right out there on the public internet. So we do that by clicking into it. And if we scroll down, you'll see our network interfaces. So here's that network interface again with its private address. If you edit that, where it says floating IP addresses, you can reserve a new floating IP addresses. And floating IP addresses are real internet routable IP addresses that you can essentially buy in your IBM Cloud account. So it's $1 a month to have an address. So I can delete this server and I'll still have this address in my account, and I can assign it to a new or a different server. But again, just be aware, it's another $1 a month, which is of course nothing compared to your $3,500 a month for this server. But it's $1 a month for that IP address. So now my system Z has an internet IP address, 169.59.191.89. And if I go out to my terminal again, let's ping that. So it's already responding to pings. That's good. I suspect it's not ready for connections yet, but we can try to connect with SSH. I'm going to use the SSH private key for the public key that I configured up in the web console. And the default username is IBM user. So IBM user at the public IP of your mainframe. Yep, so that's not quite ready to go yet. I'll just hit Control C there. But that's okay, because there is something we can work on in the meantime. If you look at the documentation, and if you look at connecting to virtual server instances, it tells you initially you have to connect over SSH, as we've mentioned. Here's how to do that. And then when we're connected over SSH, we can run a TSO command from Unix System Services to run a rackf command that alters the user and sets the password. Because, of course, we need to know a password to log in to TSO. There is no SSH private key authentication to a TSO ISPF session. But the important thing after that is they are running 3270 over SSL with a self-signed CA certificate on port 992. So we're going to need to add a firewall rule to allow us to connect to port 992 over the internet to our mainframe. So if we go back to our virtual server instances here, you can see this Ethernet interface has the security group, anger, tastiness, and so on. If we go to that security group, and if we go to rules, this is where you can see we're allowing port 22 from anywhere. We're allowing ICMP type 8, which is pings from anywhere. So that's what the VPC creation set up by default. Remember when it had those checkboxes for allow SSH and allow ping. We're just going to add a new rule to this firewall, and we will allow port 992, TCP port 992. And if I were good, I would probably just use my home IP address so that random people on the internet who try and connect to port 992 on my server's IP address won't be able to, even attempt to get through the firewall. But since this machine's only going to live for a few minutes, I'm just going to say any. So anybody on the internet now will be able to connect to port 992 on anything in this subnet, I think is the way that these security rules work. Or I guess anything that uses this security group. So it may be that you can restrict, or different interfaces can use different security groups. I'm not quite sure how all that works in the IBM Cloud. I've never used it before. But in any case, our Z instance, that Ethernet interface is in that security group, which is going to now allow port 992 connections to its IP addresses. So that's really all the setup we need to do. Let's see if it's accepting SSH connections yet. Yeah, there we go. Okay, so it didn't take a horribly long time. But again, we did need to wait for ZOS to IPL to get to the point where the SSH service is running. So I'll enter the, trying to enter a passphrase and talk at the same time. I'll enter the passphrase for my SSH key. And we're in. So we're logged in as IBM user. We're in the Unix system services on our mainframe. You can see it, of course, still identifies itself as OS 390, but it's now ZOS 2.4. And we already have a couple files here. This common CA cert. This is the CA certificate for the TLS listener, the 3270 listener. So we're going to need that to make our 3270 client happy and willing to connect. But let's go back to that documentation for a second, which is over here. And we can grab this command to change our password. So I'll copy that and let's paste that at the prompt here. So TSO command, this is just a Unix command that allows us to run a TSO command. So alt user, alter user is a rackf command to change the user IBM user, set its password to system12, and then mark the password as not expired. Obviously, and especially because we opened the firewall to the world, you would pick your own password here, but I'll just use system12 since... Okay, invalid keyword resume. Apparently resume isn't actually something we should have on the end of that. And that applies that password. So now, theoretically, anyone in the world can connect to port 992 with a secure 3270 client and log in as IBM user with password system12. So C3270 is very picky about enforcing SSL certificates and everything. So if I look at, let's look at this common CA cert file again. One note, if you follow the directions here and use SCP to copy that CA cert to your local system to use with C3270, it's going to come across as an EBCDIC file because, of course, it's sitting on an EBCDIC character set mainframe, and SCP doesn't know, like, oh, I should do text conversion on that. So I think you can tag files in the Z file system, and it tries to do translations. And there's the whole ASCII versus EBCDIC thing is, of course, a major annoyance when using z/OS Unix system services. And so there's a lot of tools and system level support to deal with that. But let's try copying this. I'm curious if C3270 will just work with the EBCDIC version of it. Let's look. So we can log off. Let me copy that command. We'll just put it in the current directory, and we need to copy it from our machine's IP address. So this is just using SCP IBM user at our mainframe at /u/IBM user /common CA cert, copying it to our current directory. I need to tell it what SSH key to use, which is IBM Cloud. There we go. Of course, you can set up an SSH agent and store your key in your SSH agent so that it's available and you don't have to type in your passphrase each time. But that is not the point of this video. Okay, so if I look at this common CA cert file, yeah, you can see it's just a bunch of gobbledygook. But XXD has a -E option to do EBCDIC decoding instead of ASCII decoding. Now you can see that it is, in fact, just a regular PIM-encoded CA certificate. So I don't know if that'll actually work with C3270, but we'll give it a try. So we're going to connect to our mainframe on port 992 using that CA certificate. What's the command? Was it CA cert file? CA file. Okay. CA file. Yeah, it can't load that file because it's EBCDIC. So let's just remove that. And if we go back to our machine, I'm just going to copy and paste this into a file. There we go. So now C3270 CA file, it should be able to read that file. Hostname mismatch. Okay. So like I said, C3270 is pretty strict about all of the TLS stuff matching up. So the problem here is if we go back and we look at our virtual server instance, the host name on the certificate, it generated it with its private IP address. But we're trying to connect with the public IP address, which is not the machine's subject alternate name or common name in its SSL certificate for 3270. So we need to tell C3270 to accept the host name 10.241.64.4, even though that's not the host name or IP address we're using to connect to our machine. So I'm going to copy that IP address. And if I look at the C3270 help again, there's an option called, it should be with the TLS stuff. Yeah, accept host name. So host name to accept from server certificate. So let's use our 3270 command again, accept host name. And then I'm going to paste in that internal private address, but that's the address that's in the host name field on the server's certificate, even though we're connecting to the public IP on port 992. So I'll hit enter here. It will try to reconnect. I think the machine's probably a little sluggish right now because it's still running more IPL tasks. And we're in. So this is our very own instance of z/OS 2.4 that nobody else has access to. So we can log in as that IBM user who has RACF special authority, right? We will be able to do anything we want on this. We can delete the nucleus. We can delete all the system parameters. We can get this thing to the state where it will never IPL again. And nobody's going to stop us, right? We just go back to our cloud console and delete it and recreate a new one if we screw it up so badly that we can't even connect anymore. So note, you don't do logon IBM user. You do TSO IBM user to log on as a TSO user. My password, what did we say? System 12, I think, was what the documentation used as a default. Yep. Okay, so now we get the TSO logon panel. This is a little bit different flow than when you directly log in with the TSO panel, but that's neither here nor there. You can just hit enter here. And we're in. We can start up ISPF, and we are in ISPF, of course. You can customize ISPS as you like. I do not like to tab to action bar choices, so now I can just hit the home key to return to the command line, and the home doesn't take me all the way up to the action bar. You can see we're able to browse, sys1 parmlib. So here's all of the parameters for the system. It's a pretty complete distribution. I think we have a DB2 instance running, although I'm not sure what the DSN is. There's a CICS instance running, but again, how you would add new transactions and stuff, you'd have to look at how the system is set up and figure all of that out. There are some common compilers. In fact, if I think z/OS user, how do I get to, Unix shell number 11. This is not the actual OMVS shell. How do I get to OMVS? I don't know. We can SSH back in, but I noticed it even has the Go language for System Z for z/OS already installed and integrated into the system. So it's a relatively up-to-date image with all of the latest bits installed. We can go back to user SDSF. So this is where you'll see all of the jobs and held output. If I go status of jobs, we can see everything running, although I think it's probably filtered to our prefix. Yeah, let's just set the filter to star. So there we are. So you can see we have HZS proc, that's the z/OS health checker. SDSF itself is running. The network services are running. All of these BPX AS jobs are Unix system services. RACF is running. So this DB stuff, so DB2 is running. CICS is running. Anything else interesting here? TSO, of course. The FTP server, that's convenient. Again, you need to open a firewall rule or have a jump host inside of your VPC, just like a Linux box that you SSH to, and then that would have full network access to your Z system. This is the Angel process and the server process for what's it called, ZOSMF, that web services based API to manage your mainframe, and it also has a web, like an end user web front end. So again, I don't know what ports these are running on. You'd have to. Some of this is in the documentation, but I think a lot of it you just need to look through all of the startup parameters and the configurations set up in the system itself here, and just sort of discover where things are, what's running, how they're getting started up. But yeah, we are in a full, right? I can go into RACF. So this is the RACF ISPF panels if you've never seen them. I can look at my own user. So if I display IBM user, you can look at this TSO segment. You see the base data, IM indeed, special. So this is the RACF special attribute that lets you fully manage RACF and the system. And we have our TSO information here. So yeah, that's all the RACF stuff. Like I said, I haven't really poked around this too much, but I think once you're in, probably first step is just start looking at the IPL parameters. And you can sort of trace from here where all of the system settings are going to be coming from. And so you can look into the, particular configurations, particular subsystems that you're interested in. So I'm going to log off and log off. And that takes us back to our login screen. Looks like this comes from a group in Canada. I assume Toronto, given that their little ASCII art here, or EBCDIC art, I guess it would be, is that Toronto Tower, CN Tower. I think it's called the CN Tower. And so, yeah, notably, this is not, it looks like it's not based on the AD CD image maintained out of Dallas. I think this is a different development and test image that this different group maintains. So you can type log off again at the network solicitor screen. The logon commands, like if you want to log on to TSO, that will take you then through the TSO logon procedure if you don't directly say TSO IBM user. So that's kind of how this system is set up. But I will just, I think I get it. Yeah, F3 here will log back off. Log off from that, and I'm disconnected. So the most important question at this point is, how do I not spend $3,500 on this? So after you've had your fun with your ZOS instance, all you need to do is come back to your virtual server instances, scroll all the way over to the right, and then in the actions menu here, you just say delete. And type delete to confirm. I'll delete that. There may be options where you can shut the machine down and but keep the disk around and keep the machine definition around. So you'll pay the 2 cents an hour or whatever it was for the hard drive, the DASD, the disk images, but you wouldn't be paying for the online time. Now, I don't know if that ZOS license still gets charged, right? You'd have to be careful and actually read the IBM Cloud documentation and pricing guides to make sure that shutting a machine down really does stop billing most of that hourly price. So the safest thing to do, of course, is to just delete that instance. So you'll see that instance is gone. And if we look down in block storage volumes, the block storage, so its disk images, have also automatically been deleted, so you're not paying for those anymore. The only thing that sticks around is that floating IP address, because you add floating IPs to your VPC, not just to specific instances. You bind them to instances. You can see this is now unbound because I deleted that virtual server instance that I had it bound to. But this is that $1 a month address. Now, from what I've been able to tell, as soon as you create this address, it bills you for the $1. So this address is mine for the whole month, and then it will bill me $1 again next month if I still have this address. So if I delete this address now, if I release this address and then create a new virtual server and ask for a new floating IP address for it so that I can get to it over the internet, it will charge me another $1 for that new address I asked for the month. So if you do plan on deleting your server, but then coming back, a couple days later tonight, spin it back up again, start paying your $5 an hour for your Z server, you may want to just keep this floating IP in your account because, again, it's not going to cost you anything until the next month when it charges you another $1 to renew it. But if you're deleting it and recreating it each time you make a Z instance and delete your Z instance, you're going to be paying $1 each time, not just an aggregate $1 for the month. So something to be aware of there. So I'm going to keep that for now because I'll probably take a closer look at how that ZOS system is set up and what else is in there later. But again, when you're ready to release that IP address, you do release from the actions. If I look at my resources here, we can confirm that under VPC infrastructure, we're just back down to our VPC and our security group. The actual server and disk image is gone. So I shouldn't be getting any big surprise bills from IBM now. Unfortunately, those floating IPs don't show up in this list. So this isn't a definitive list of things that might cost you money because we know we have that floating IP address out there somewhere that's going to cost us $1 a month. So again, I really wish the cloud providers had a list, right? Just here's everything you're currently using that costs money so that I can delete everything and be sure that I deleted everything, right? If I didn't know that I had to go into VPC infrastructure and go into floating IP addresses to even see that I have something that costs money, I wouldn't know to delete it. And for something that's $1 a month, that's not a huge deal. But what if there was something hidden in one of these that you had created that costs $100 a month or $3,000 a month? So yeah, you can set up spending alerts and stuff. But I just wish the clouds made it easier to not accidentally spend money when you really don't want to. Nevertheless, that's neither here nor there. Hopefully this was a good, quick intro to how you can get your very own ZOS 2.4 system that you are the IBM user on up and running pretty quickly. And again, I think for hobbyist purposes, for using it a couple hours at a time, especially in the first month when on a new IBM Cloud account, it looks like you get $200 of credit. It's kind of nice to be able to do. This isn't something that has been easy for us hobbyists to get our hands on for a relatively low price until this cloud offering came along. So have fun with it. Don't accidentally get billed for thousands of dollars worth of services. And if you have any comments or questions or interesting stories about your own experience with IBM Z systems up here in IBM's cloud, leave them in the comments down below. Thanks so much for watching, and we'll see you next time.